Hi. So this is just going to be a really quick tutorial on using Z3 in Rust. This is mostly going to be targeted towards people who kind of have heard of Z3 and know what it's about, but maybe aren't too familiar or haven't used Rust before. Yeah, so without further ado, let's just get started. So I have a basically new cargo project here. I have some boilerplate, but we'll get into that in a second. But the first thing that you want to do is you want to add Z3 as a dependency. Oh goodness, I'm so sorry. First thing you want is just cargo add Z3. There you go. You've added it as a dependency. Great. Next thing you want to do is you want to make sure that you have the Z3 binary installed on your computer. Uh, I'll have the latest version of Z3 linked in the description. But you can also just add static link Z3 to the features part of the dependencies. I personally would recommend just downloading Z3 just because your initial compile time will be very long without it. And also, it's just nice to have Z3 just on your machine. So that's what I recommend. Uh, Next thing, we can get started on the actual code. You don't need to worry about any of this except for the solver right here. This is basically the most important part, is going to be how you assert different stuff and actually find the model for it. So just as a quick demonstration, we're just going to assert that a boolean is true and then find the model for that. So first thing you want is to actually create the boolean. We'll call it b for bool, and we want to create a new const. You want to pass in the context of this specific solver that you created, otherwise it won't work. And then just create a name for this. We're going to call this just b. Great. So now we have a boolean struct or a bool struct, and we want to assert that it's true to the solver. To do that, we just do solver.assert ampersand b. This is providing a reference to the bool for the solver because the solver doesn't need to mutate it. And afterwards, after the solver uses or does what it needs to assert that it's true, then you'll be able to use b outside of the assert. This is you have to do this because of the ownership model of Rust. If the API just took the actual Boolean instead of the reference, then we would no longer be able to use the bool after the assert is called. So that's why you have to use the ampersand b. You might have already known this, but it's nice to just get a refresher. Yeah, so now we want to we want to create the model for it. So to do that, we just need to use the solver.check method. We're going to use a match statement here to match over all of the possibilities of check. The check function will return a sat result, which only has three options. It's either sat, unsat, or unknown. So we can go ahead and put all those in here. So sat and unsat and unknown. Perfect. So unknown is the easiest to unknown and unsat are the easiest to handle. Those are basically, or unknown is basically when something weird happens. Usually this is just you've controlled C, you've interrupted the process, and you interrupted it trying to find the model, so it'll just return an unknown and then continue on. So you can just say something weird happened. No, and that's gone. Whatever. Um, for unsat, this is just the model couldn't find anything. It searched through everything, couldn't find a satisfied model. That's fine. Just print line, no model found. frowny face. Okay, cool. And then sat is where we have interesting things. So now we have a model. The solver knows a way that all the assertions are true. How do we get that? Uh, all we need to do is we can grab the model by getting solver.getModel. Great. So now we have our option model. We need to call unwrap. In a real application, we shouldn't be, single letter variables and like you shouldn't be using unwrap. You should have a little bit more robust error handling, but we're just going to use unwrap for everything for now. But again, in a real application, be better than me. Don't use unwrap. Right. So now we have our model. We can extract what each variable in the model is by getting the by calling model.get const interp, and we can pass in our AST. So in this case, that's the boolean b, and we will let result equal boolean b. And again, for everything, we need to unwrap what this is. Oh, I should also mention, by the way, these nice highlighting things. If you haven't already, if you don't already know, you should download the Rust Analyzer for VS Code. You probably already have it, just to be sure. And yeah, now you have the result in terms, but it's in terms of a bool struct, and that's not what we want. Usually, when we have something like this, we want it in terms of like an actual boolean in Rust, right? Like the actual true or false. So to get that, what we actually need to do is let's just, if we just try to print the result, it's not going to be what we actually want. We want true or false. So we would want to call the as bool function and then unwrap that so that we, again, we grab the actual thing instead of the option, or the, is it the option? I forget. What was it called again? Yeah, it was the option. I was right. Yeah. So we can go ahead and do a cargo run, and what happened? What? Oh, I didn't save my file. Okay, oh, uh-oh. Yes, so now we have true. Great. Um, we can also assert the negation of the bool here by doing cargo or b dot not, and again we get false. Great. Now we're gonna get into integers. So let's say we have x, new integer x, new const, pass in the context, pass in the name, and let's do that again for y as well. Great. And if we want to assert that x equals y, what we will need to do is solver.assert ampersand x dot underscore equals ampersand y. The reason why we have this underscore equals is because I think int satisfies or implements the equals trait, and that uses the regular equals or regular EQ function. So that's why I think we use underscore equals. I didn't write this, so I don't know everything, but I'm pretty sure that's why. And again, we use ampersand here because otherwise we wouldn't be able to use y after the fact, and we use this ampersand here because again the solver, the API uses a reference as the as part of its API. Okay, just basic stuff. Again, if we want to say, for example, we're going to get the same model after it checks again. So we can go ahead and let's just do print line x equals this, and we're just going to get model dot get const interp, pass in the x dot unwrap, and we'll do the same for y. Cool. You know, again, this is just gonna find like any because of how Z3 works, it's gonna find just anything. So in this case, it found, if x and y are both 0, then they're gonna be equal to each other. That's great. If we wanted to say, for example, also assert that I don't know, that like y is also equal to like 1, we can create a 1. We can pass in 1 as a int struct just by doing int from u64, again passing the same context, and we're going to do 1 here. It is mad at me because we did not pass it as a reference, so make sure you have your ampersand in the right place. And now if we go ahead and cargo run, we can see that they are both 1. Great. Now we're going to do something just a little bit more complicated. What I like to do when I first got this was I wanted to create a Sudoku solver, because I love my little puzzles. But I ran into some troubles because I didn't really understand how Rust handled slices and stuff, and that's used in the distinct function. So we're just gonna like quickly we're gonna just figure out how we're gonna do the distinct constraint of C3. So we're not gonna implement an entire Sudoku solver. I recommend that you try it for your first project or whatever you're trying to do as just as a first step. Yeah, so first thing we want to do is let's just create a vector of 9 ints. So let's let vec equal well, let's call it nums equal vec of you know what? Let's be even. Let's be even more. I don't know what the word is, but let's just go through for I in 0 dot dot 9. Let's just create. Let's just do nums dot push. I just realized we need to let nums be mutable because Rust has everything be immutable by default. Yeah, so we're just gonna create 9 new vecs, or nine new ints in our vec, passing the same context. Again, we're gonna pass it through the same solver. So same context, and let's create names for all of these by using just the format string. This is how format strings are done in Rust, I think. Maybe there's maybe there's a better way to do this. I'd love to know if you happen to know. Comments or something. And let's just do num hyphen I. I think that will work. I think that works pretty well. Cool. So now we have this. Another important thing about a Sudoku is that we want each number to be between 1 through 9. So to do that, let's just do solver dot assert, and for each one we would want to assert that. So nums I. This is not like the best, like most efficient way of doing things, but this is just a quick start guide. I'll let you handle making things more efficient. So we want this to be less than or equal to, again, how to use the const I'll just copy this here. And instead of that, let's do 9 and ampersand. Great. So now everything is less than or equal to 9, and we also want it to be greater than or equal to 1. All right. So that's the first bit. Now all of our numbers are between 0 or between 1 and 9, and now we want to make sure that they are all distinct, right? This is what kind of tripped me up. So we're gonna start it, same as usual. We are going to do int. I think distinct is right here. Same context, but this values. This is what tripped me up. So maybe this is gonna trip some other people up too. This ampersand slice, this slice. I was very confused because I have all of my numbers in a vector. So I thought, oh God, do I have to convert this vector into a slice? Turns out, no, you don't need to do that. It's all fine. Uh, it would be a problem if we had a slice and the API wanted it in terms of a vector, but it's totally fine to just pass in a vector when it wants a slice. You're fine with that. So what we want here is, again, we're passing in a reference. We just want nums. So like this, except if we do try to do this, it's going to be mad at us because I just said that. It's fine. What's the problem here is it wants references to ints, but we have a vec of just the ints. So in this case, what we want to do is just pass or get an iter and collect everything into one vector again. Oh gosh, everything is there we go. And now it's fine. Basically what I did here is when I call the iter function, it creates an iterable or iterator. I'm so stupid. An iterator of the nums, and iterators only grab the references to the nums, not the actual nums, because again, we would like to keep using each of those, like each of the individual ints after the fact. So iter only takes references to those, only grabs references to those ints, and then when we immediately collect it into a vector, we're now just grabbing, or now we just have like a vector of those references that we wanted. So now we can assert that all of the nums are distinct from each other. They're between 1 and 9. So if we want, we can now go ahead and get for num in nums. Go ahead and just do print line. We can just get the model dot get const interp of ampersand num. Oh, what is it? Oh, yes, and we want to unwrap it. Right, okay. Do cargo run, we can see. Ta-da! We get all the numbers from 1 through 9, which is great. This is exactly what we wanted. Yep. So basically, that's my very quick tutorial on using Z3 in Rust. If you end up using Z3 and create a cool project with it, I'd love to see it in the comments. I'd love to see really cool stuff, and yeah, I hope this is helpful and that you can create cool things. Yeah. Hope you have a good day.